Hello, good morning, students. Today we will discuss about the relations between linear velocity and angular velocity. Because we have seen in our previous lectures, that is, which parameters are there in case of circular motion. These circular motions means what? Which types are there? Which parameters are there? That's like radius vector, then angular displacement, angular velocity, angular accelerations. Okay, so all of these things we have seen. So let us start in our today's videos, that is relations between linear velocity and angular velocity. Linear velocity and angular velocity. So for that purpose, we are considering here one object or one particle. It is performing circular motion. So one circle is here having center O, and this one is the radius vector R. The particle is at point A. If it goes from A to B up to this point, then we get here radius vector R. So this is B point. So when the particle goes from A point to B point, there is a delta theta at the center of circle. We know what is the meaning of delta theta? That is the angular displacement, which we have seen. Okay. Now, when it goes from A to B, then it is called as delta S, linear displacement. Okay. So suppose here a particle is moving along the circumference of circle. It means that if it is performing circular motions, so then what is the relations between its linear velocity and angular velocity? See here the notation for linear velocity and angular velocity. Linear velocity, that is small v stands for what? Linear velocity. Linear velocity. And omega stands for what? Angular velocity. Angular velocity. So in this article we have to prove the relations between these two velocities. One is linear, another is angular. See here, an object goes from A to B. So when it goes from A to B, there is linear displacement, that is delta S. So if we want to write a formula for linear velocity, how we can write? We know linear velocity of a particle. Linear velocity of particle V is equal to, that is linear displacement upon velocity, displacement upon time. So linear velocity, so linear displacement. Linear displacement is delta S upon delta T. Displacement upon time. So delta stands for what? Linear displacement. Linear displacement upon time. So in short, linear velocity is called as linear displacement upon time. So these concepts can be written as हा concept आपल्याला या पद्धतीने लिहिता येतो. V is equal to delta S upon delta T जर असेल तर आपल्याला याला लिमिटच्या फॉर्म मध्ये लिहिता येईल. V is equal to limits delta T tends to 0 delta S upon delta T. Means time is not exactly equal to 0, it approaches towards 0. Means we can say it is a very short interval time. So velocity is equal to limits delta T tends to 0 delta S upon delta T. But in our previous videos we have seen what is delta S. Linear displacement means what? Okay. So what is the exact formula for linear displacement? So for linear displacement, we can write for linear displacement. What is the formula for linear displacement? Linear displacement is equal to r multiplied by delta theta angular displacement, which we have seen in our previous videos. In case of angular displacement, we calculate this formula. That is, linear displacement is exactly equal to radius multiplied by angular displacement. So we can use here this concept. Okay, so how we can write? So instead of this delta s, we can write the value of r into delta theta. So suppose this one is the equation first. So equation first becomes, that is, v is equal to limits delta t tends to 0, delta s. Instead of delta s, we can write r into delta theta upon delta t. Okay, so this r, it stands for radius, and radius is always constant throughout the circular motions. तर माहिती आहे रेडियस जी असते ती रेडियस कशी असते, कॉन्स्टंट असते. ठीक आहे, सर्कलची रेडियस कॉन्स्टंट असते. म्हणून हे कॉन्स्टंटवर काय प्रॉब्लेम बाहेर काढू आणि आपले जे इक्वेशन्स येईल ते इक्वेशन्स काय येईल. सो therefore velocity is exactly equal to r into limits delta t tends to 0 delta theta on delta t. ठीक आहे, आणि हा जो r आहे हा r आहे कॉन्स्टंट. मग डेल्टा थीटा अपॉन डेल्टा टी म्हणजे काय, तर डेल्टा थीटा अपॉन डेल्टा टी स्टँड्स फॉर डेल्टा थीटा म्हणजे काय लिहिणे, अँग्युलर डिस्प्लेसमेंट अपॉन टाइम. अँग्युलर डिस्प्लेसमेंट विथ रिस्पेक्ट टू टाइम, the ratio of angular displacement with respect to time stands for what? Angular velocity. Exact, correct. That is, it is omega, and omega stands for what? Angular velocity. It is angular velocity. So therefore, v is equal to r into omega, and this is the most important concepts to solve the problems depends on linear velocity and angular velocity. Okay, you should know the relations between linear velocity and angular velocity. V is exactly is equal to r omega. Okay, so if you calculate the value of omega, then you will use, that is, v by r for omega. So this is very simple concepts and related to the linear velocity and angular velocity. You should know, remember, that is linear velocity and angular velocity, they are right like this. That is, linear velocity is exactly equal to the product of angular velocity and radius. Okay, so next topic we will discuss in our next videos. Till then, bye.